GitLab is the faster path from idea to software. It's more than a code repository. It's one workflow that brings development, security, and operations teams together. No walls, no endless feedback loops. Use GitLab end-to-end or integrate it with the tools you love. And it lets you eliminate the rest to help reduce costs and boost productivity at the same time without trade-offs. With GitLab, teams can build software faster, automate software delivery, shorten cycle times, and increase developer productivity. And security is built in, not bolted on. Scan for vulnerabilities with every code push, automatically. It's the entire development process, all in the same place where everyone works. Because we're on this path together. The path from idea to collaboration to higher performing teams. With one comprehensive, innovation-driving, fast and secure DevSecOps platform. Software faster. GitLab.
Hello, and welcome to today's GitLab webinar. Thank you for joining us. My name is Brian Miller. I'm a customer success engineer at GitLab, and today we'll be providing an overview of GitLab runners. The topics we'll cover today include what are runners? What is the purpose of runners? How do we use them in our pipelines to perform tasks? And then at the end, we'll wrap up with some best practices around the use of runners. Just a reminder, we have panelists standing by to answer questions. If you have questions, please look at for the Q&A button at the bottom of the Zoom window and ask them there. If questions are asked in the chat window, they may be accidentally overlooked. What are GitLab runners? GitLab runners are essentially software applications which perform the tasks defined in pipeline jobs. Each task in a pipeline is executed by a runner. Runners can live just about anywhere and are supported by a number of compute architectures, which we will look at further in a minute. As a note, you will need at least one runner in order to run a pipeline. A GitLab runner executes CI/CD jobs such as build, test, and deploy. Runners support pretty much any programming language, and they can run on any platform that supports Go. Runners also support autoscaling. What that means is the ability for them to spin up and down different VMs, Docker containers, or Kubernetes pods to process builds immediately, thereby minimizing our time and cost. Each runner can have multiple processes. As a reminder, a runner is software, so one runner can have multiple copies, and one runner installation can register multiple runners. As I mentioned, runners are supported on a number of different compute architectures. We have, of course, the x86 commonly used, ARM 32 and 64. We have the Power PC Little Endian, and of course, the venerable IBM S390. As a footnote, I have a runner installed on my Raspberry Pi server, which is ARM 64, which helps me maintain updates and patches for my Pi-hole application. At a high level, one GitLab instance will require at least one runner and will most likely have dozens or even hundreds of runners. As we mentioned earlier, runners can be virtual machines, Kubernetes pods, or could even be the developer's laptop. Runners use a polling method. GitLab maintains a queue of jobs that need to be executed, and the runners poll GitLab asking, "Do you have any jobs matching my configuration?" If GitLab says, "Yes, I do," then the runner will pick up that work and perform the tasks. This kind of runner architecture allows you to have your runner in a completely different network from the GitLab server, which is great if you want to keep your source code in one network and the runners on another, which is a common configuration. The GitLab server doesn't necessarily need to know anything about the network that your runner is in. The runner just needs the ability to reach into that network containing the GitLab server. Runners phone home to GitLab, meaning they initiate the communication process, which means the GitLab server doesn't need to know anything about them. Diving deeper into the architecture, we see within the GitLab server, we have the GitLab repo. Inside of the repo is our GitLab CI YAML file. This is the first of the two user-facing parts of GitLab CI/CD. The CI YAML file is where pipelines are defined using the YAML language. Also inside the GitLab server is the pipeline coordinator. The coordinator controls the job queue for the entire server. GitLab runners, the second of the two user-facing aspects of GitLab CI/CD, are constantly polling the job queue looking for jobs they're allowed to run. When the runner sees a job that it can run, it will grab it out of the queue, pull the code, and run the job as specified in the GitLab CI YAML file. There are three different scopes for GitLab runners. Runners can either be shared, group, or project level. They can be tagged or untagged, and they can be protected or not protected. Shared runners are available to every project in a GitLab instance. So it's not uncommon to have shared runners when you have multiple jobs with similar requirements. Rather than having multiple runners idling for many projects, you can have a few runners that handle multiple projects. Shared runners process jobs by using a fair usage queue. Essentially what that means is that there's a fair usage algorithm that assigns jobs based on the projects that have the fewest number of jobs already using those shared runners. So we have shared runners at the highest scope, our instance. Then group or project level runners are at a lower scope. And so, for example, if you have jobs with specific requirements like a deploy job that requires credentials, or perhaps you have some kind of job that produces a huge amount of CI activity, you may want to keep that runner separate from other runners. If you set up a runner to be used by multiple specific projects, we would call that a group runner. If the runner is only available to a specific project, then we would call that a project runner. We can also have tagged runners. Tags allow us to select a runner from a pool of runners using a tag matching algorithm. Tags are used to ensure that the correct runner is working on the correct job. For example, a Windows build job, which we see here on the screen. We could even specify a specific version of Windows with our tags. Maybe we want to separate testing Windows 10 from Windows 11, for example. Runners should be created for all the different types of jobs that are used in a pipeline and tagged appropriately. Now note that GitLab CI tags are not the same as Git tags. CI tags are associated with runners, and Git tags are associated with commits. By tagging a runner for the types of jobs it can handle, you can make sure that runners will only handle the jobs they're equipped to run. And lastly, we also have the option of using protected runners. For our regular fare of build and test types of jobs, we would most likely use non-protected runners. However, with deployment runners, we have to be careful with sensitive information. For example, they may contain production deploy keys or some other credentials that we want to ensure are protected. You can protect runners so they don't reveal that sensitive information. When a runner is considered protected, the runner will pick up jobs created on protected branches or protected tags only, and it will ignore all other jobs. GitLab recommends protecting the runner if it contains deploy keys or other sensitive capabilities. Let's review the types of runners we've talked about so far. So we have shared runners, which is that high level, can be used by any project. Typically, they would be managed by the GitLab admin. Most often, they would be set up to be auto-scaling. Then at a little bit narrower scope, we have group and then project level runners. Those are going to be tied to one or more specific projects for groups or tied to one specific project for a project runner. Those runners are owned and managed by the runner owners. Typically for specialized builds or if an org needs to do so for billing. So it's not uncommon for organizations to do maybe chargebacks for runner time. And one way to do that is to set up project or group runners which are billed back to a specific organization. Then we have tagged and untagged. So as you recall, tagged are used to run jobs that have the same tag so that we know that our runner is capable of executing the work that our job is requesting. And then untagged runners can be used to run jobs with no tags. Protected runners only run jobs from protected branches or protected tags, and they're used typically for jobs containing deploy keys or other sensitive capabilities. Non-protected runners, which are likely the bulk of the runners, would run jobs from any branch and are used for any build. GitLab runners implement a number of executors that can be used to run your builds in different contexts and environments. Looking at our chart here, you can see we have Shell, Docker, Docker Machine, Kubernetes, SSH, Parallels on Mac, and VirtualBox. The two most common executors are Shell and Docker. We'll look at each one of these in more detail. So the shell executor type runs a job locally. It's almost as if you're sitting at the command prompt in a terminal. So if you say something like, echo some environment variable, it's just as if you sat there and typed that out. SSH is very similar, except that you are running the job at the terminal on a remote system. Docker is the ability to execute a Docker container. The runner host, of course, must have Docker installed so that it can do that. Red Hat's Podman is also supported. We also have a Docker machine executor type, which allows us to do auto-scaling of virtual machines managed by a GitLab runner. Kubernetes is also supported. That allows us to run jobs in containers on pods in a Kubernetes cluster. And then these next two, which are still in beta, are GitLab's latest executors. They are newer versions, which we'll talk about here in a minute. The Docker Autoscaler is used to scale Docker containers, and it's meant to replace one of the existing Docker Autoscalers. And then the Instance Autoscaler is used when jobs need full access to the host instance, operating system, and attached devices. The instance executor can also be configured to accommodate single and multi-tenant jobs with various levels of isolation and security. The instance autoscaler supports nested virtualization. It's important to note, however, that nesting is only supported on Apple Silicon instances. Last but not least, you have the ability to create a custom executor type. If there is an environment that you would like a runner to execute in, and it's not currently supported by the other existing executors, you have the ability to create your own custom executor. If you're not sure which executor to select, there is an I'm not sure section in the documentation, and you can look to see which executor would be the best fit for your scenario. This slide may seem a little out of place since this is a webinar talking about runners, but I find it helpful to present the bigger picture here and keep it in mind throughout the webinar. Beyond the runner technology that we're talking about is a process that'll ensure you get the most from your investment in GitLab. What's depicted here on the screen is what we call the GitLab flow. The GitLab flow is a process we recommend for DevOps teams to follow while using GitLab's capabilities within a concurrent development lifecycle. If you look at the top, you can see there are 4 different sections: plan and create, integrate and verify, deploy and operate, monitor and improve. On the left here, we have the plan items that you're familiar with, probably epics, milestones, and issues. These are different ways of keeping track of work that's planned, envisioned, things that may be looking out into the future. And then at some point, an issue is assigned to a developer. The developer then creates a merge request, signaling that they're going to begin work on a specific issue. At some point, they're going to make code changes, commit, and push their code, which will kick off pipelines using the runners that we're talking about. The first thing that probably would happen is some kind of build or automated testing, then scanning of some kind. Maybe it's secrets detection, maybe it's static and code analysis. At some point, then we'll get to collaboration and review. If there are changes to be made based upon any of these items that happen during the pipeline, the developer will go back, they will make some changes, they will push their code again, have commits, and we'll start this virtuous cycle all over again. At some point, if the application is some kind of app that runs in a web, as a web app, then it could be deployed to a web review app, which allows the collaborators and reviewers to actually view the application running in an ephemeral instance. Once that is completed and there is approval for that merge request, the merge can be accepted, and then we begin different portions of our pipeline, the release and deploy and monitoring sections. So just stepping back, that's a big picture, and we'll keep that in mind as we start to talk about, okay, how do runners fit into this, and where do jobs and stages and all those things fit? Let's take a look now at a high-level example of a pipeline with some different CI and CD elements. So you notice we've got our developer here doing code commits, and then we've got CI portions of the pipeline and CD portions. In the CI portion of the pipeline, we have building, which is a very typical step, and then we have running our integration and unit tests to check to see if our code is valid. We may then look at a live preview of the development branch with our review app before merging into stable. In the CD portion, we may deploy to multiple environments like staging and production, and support advanced features such as canary deployments. Then lastly, we may monitor performance and status of the application running in production. Let's step back a minute and look at the terminology that GitLab uses for describing a pipeline. So when we talk about a pipeline, the pipeline is the largest unit of work to be done, and typically it's going to be organized into stages. Stages are a logical grouping of jobs that pertain to a specific phase of the pipeline. Things in a stage can be run in parallel, which improves performance. And if you think of stages, typically they're going to be things like build, test, deploy. Those are all stages. Inside of our stages, then we have jobs. And jobs are the actual task that needs to be performed. An example of a job could be something like running npm test or Maven install, or maybe we kick off a bash script or a shell script. And then last, we have environments, which point to a deployment destination. Environments give us the ability to define a different destination, where it lives, who has access to it, things like that. All of these items are defined in one YAML file, which is versioned and then stored in the repo that it pertains to. Pipelines, as we noticed in the previous slide, are comprised of jobs and stages. So if you look down here at the picture on the bottom, you'll see that we have 5 different stages. Each one of these stages is comprised of one or more jobs. All the items in a stage can run in parallel, but typically a stage will wait for all the jobs in its stage to complete before it advances to the next stage. So thinking about this broader, jobs define what we want to accomplish in our pipeline. For example, a job that compiles or tests code. Stages then define when and how to run jobs. For example, stages that run tests after stages that compile the code. By default, a pipeline will have 3 different stages: build, test, and deploy. Having default stages does not mean the users have to create a job for each stage, for stages with no jobs will simply be ignored. Jobs are executed by runners. Multiple jobs in the same stage are executed in parallel. If all jobs in a stage succeed, the pipeline then moves on to the next stage. If any job in a stage fails, the next stage is not executed and the pipeline ends early. In general, pipelines are executed automatically and require no intervention once created and kicked off. However, there are also times when you can manually interact with a pipeline. It is possible as well to have a pipeline pause and wait for something to happen. So you'll notice that this little play button here indicates that in order to advance beyond this point, manual intervention is required. Somebody will have to push that play button, somebody who has sufficient permission. As your pipelines grow larger and more complex, efficiency becomes more important. One step we can take to make our pipelines more efficient is to cache job results for use in subsequent jobs in the pipeline. This is especially important when large binaries or images are created in one job and then used in later jobs. If a previous pipeline fails or a cache is somehow invalidated, items may need to be regenerated. One best practice with caching is to define which files and directories should be cached. This prevents over-caching, which can negatively impact performance. So one of the things that we recommend doing is setting up a cache path. And the cache path essentially is a list of files and directories that a job should cache. And we can use glob operators to match any character, including path separators. So if you look at our example here, we are looking at APK files and we are looking at our config files. We want to cache both of those for use in subsequent jobs. Another best practice is to use cache keys. The key prevents ambiguity and provides cache affinity between jobs. GitLab publishes recommended patterns for various languages. I recommend checking those out when setting up your pipelines. You can also tie a cache key to specific files, and that way if there's something specific, in this case package.json for a node project, we can refer to that using the cache key. One of the things to be aware of with caching is if you're using DAG type pipelines. We haven't talked about those, but those are directed acyclic graphs, which allow some parallelism and some circling back of tasks. Basically, what it allows us to do is not necessarily wait for certain jobs to be finished before others begin. And in those cases, we could have maybe access to caches by simultaneous jobs. And so locking is an issue. So one thing we might want to do for parallel jobs is consider using separate cache keys. Or we could set up a cache policy where parallel jobs only pull, and then we ensure that there is a prior job defined that makes sure the cache is up to date as required. Another consideration is early in a project, it could be that none of the pipelines are green. And what happens is if none of the pipelines are green, we're always generating cache content from scratch, but we're never using it. So one tip we could provide here is to use the when always to ensure you're not throwing away valuable cache until you're able to get your pipelines green. There are a few things to consider for caching when you have more than a few runners, which I suspect most organizations will. To help ensure that cache is available to the runner which picks up your job, you should consider using a tagged runner, using a runner specific to your project, setting up a network drive to allow sharing of cache information, or using a distributed cache. When using autoscale runners, there's even a higher likelihood that cache will not be available to the runner. And why would that be? Well, if you think about it, autoscaling means that runners are being picked up from different locations, maybe running on different machines, different hosts, so that cache data may not be available when a job is picked up by a runner on a brand new machine. One way to work around that is to use GitLab's distributed cache. Essentially, distributed cache uses object storage to keep all cache information in the same location and available to all runners. That allows them then to be able to share that across any runner that picks up the work that you are requesting to be performed. Some other things which can greatly improve pipeline performance. One of those is to use GitLab's dependency proxy. The dependency proxy essentially caches Docker images pulled from a Docker hub. So the first time you pull the Docker image, you pull it from Docker hub, but then at that point it'll be cached in the dependency proxy. Subsequent pulls then will pull that directly from the proxy and not from Docker hub. So this improves performance because you're local to GitLab. It doesn't have to reach out into the internet to bring that down. And the number of pulls from Docker Hub is reduced, and it helps you to stay below your rate limits. If you're not using GitLab's dependency proxy, which I do recommend, we recommend deploying a third-party pull-through proxy, which works in the same way as the dependency proxy, helping to improve resiliency to Docker Hub's outages and also reducing your rate limits. Consider specifying a Git depth of less than 50. This allows Git to request only the latest set of changes for a given branch up to the desired number of commits. For very large repos, especially mono repos, there are other and perhaps more exotic means to speed up job execution. And here's a link which we will leave as an exercise to the reader. This next section covers how runners are architected and some of the options available for autoscaling. So this slide highlights the execution flow of a runner interacting with a GitLab instance. You can see that initially the runner is registered and it receives a runner token. The runner executor then begins polling for jobs to run. When a job is found, it accepts a job token and begins executing the job. When the job is completed, it returns the job output and status using the job token it received in the previous step. The next 3 slides highlight some of GitLab's autoscaling options. The first is the Kubernetes autoscaler. This employs the Kubernetes executor to use Kubernetes cluster for your builds. The executor calls the Kubernetes cluster API and creates a pod for each CI job spawned. Helm, of course, is fully supported, and runners can be hosted on all the major cloud vendor platforms. This approach does require some in-house knowledge of Kubernetes so that resources can be managed to tune the cluster for performance. The next autoscaling option is the Docker Machine Autoscaler. This is the solution which scales runners out on GitLab.com. While it works very well, It is dependent on GitLab's forked version of Docker Machine, which has been deprecated. This executor will eventually be phased out and replaced by a next-generation Docker Autoscaler. Speaking of which, the GitLab Runner Autoscaling is the next generation, which is meant to replace the Docker Machine Autoscaler. Sometimes you may hear this referred to as the fleeting plugin autoscaler, even though the instance executor also uses the fleeting project plugins. This solution is currently in the beta phase with plans to go GA in Q4 of 24. The next few slides cover things to consider when preparing to establish your runner fleet. So day 0, right from the start, things to consider. Will we offer shared runners? If so, how will they be configured and who will use them? What kinds of tasks will they be used for? And if so, should each job run in an ephemeral environment? What would that look like? What things do we need to put in place before something like that can occur? Group runners. What kind of policies are needed? Who will be responsible for maintaining them? Which runners should be protected? How should they be tagged? And of course, the same could be asked of project level runners. If you're just starting out and want to jumpstart your runner fleet, setting up shared runners in an auto-scaling configuration is a good place to start. Configure your setup with at least 2 runners. It's important to have a plan to monitor your runner fleet and your pipelines so that you can begin to characterize your workload profile and anticipate where performance bottlenecks may occur, and of course, what resources you'll need to increase as that usage grows. One way to monitor runner workload and resource consumption is to use the Prometheus metrics endpoint, which is built into GitLab runners. These metrics provide a good starting point for characterizing runner load over time, as well as spotting trends. I reserved the remaining time that we have together for a brief Q&A around the topic of GitLab runners. With me today is Darren Eastman, Principal Product Manager at GitLab. His team is responsible for GitLab Runner. Darren, thank you for joining us today.
Hey, thank you, Brian. Appreciate you having me. I'm so honored to be here today.
Great. We've got a couple questions queued up. One of the ones that comes up frequently with interaction with customers is around when to use self-managed, self-hosted runners and when to use GitLab's runners. So what considerations should customers keep in mind when deciding if they should host their own runners or if they should use GitLab runners or use a combination of both?
Yeah, Brian, thanks for that question. That's a great question. And just to clarify for our customers that are adopting GitLab SaaS, which is what Brian's referring to here, we have a product manager, Gabriel Engel, who's responsible for GitLab SaaS offering. And that team has done a bunch of great work over the last few months, extending that offering. We have a bunch of capabilities on GitLab.com SaaS runners. So yeah, there are a number of different considerations. And what we hear from a lot of customers is that it kind of depends. The first thing to remember, just kind of stepping back for all customers that are looking at this video, is that if you're a GitLab.com customer, there are no restrictions in terms of that we place on you in terms of either A, you using the GitLab.com offering, GitLab.com runner offerings, or B, deciding to host runners yourself. If you need to host runners yourselves for any whatever reason, that's completely fine. It's completely available with you in terms of GitLab, completely flexible. Some considerations customers have in terms of like thinking about security and compliance. Some customers have a need where certain workloads, i.e. their CI workloads, must run in their own environments from a compliance perspective. There are also other considerations sometimes when you're running CI workloads, needing access to other resources internal to that network. So as you start to think about those considerations, then using self-managed runners for certain use cases makes sense. But even thinking about the security needs, maybe the access needs from a networking perspective, doesn't necessarily 100% preclude you from thinking about using GitLab.com runners for other types of scenarios. So for example, maybe you're you have a development team that's just kicking the tires on a new application. Well, there's nothing that's stopping them or stopping you for that matter from having a policy that says, hey, you're just testing out doing a quick build on a Node.js app. Just go ahead and quickly run that build on GitLab.com runners and so on and so forth. So you can actually have a strategy, even if you're highly secure and compliant, or company that has a lot of security and compliance needs, you can have a strategy where maybe some less secure compliant workloads, you're allowed to run on GitLab.com, and other workloads run on self-managed. Again, we provide that functionality. Other considerations are you may have workloads that run on computing or need to run on computing platforms that we are not offering on GitLab.com. For example, GitLab is one of the few CI providers that supports running CI workloads on IBM mainframes. We have native support for S390X. So a lot of our customers on the mainframe are adopting GitLab CI, adopting one of DevOps platforms, and obviously they'll need to self-manage because we don't have mainframes as of right now connected to GitLab.com. One other consideration is to wrap up this question, Brian, is if you're building, and a lot of customers these days, whether they are software startups or traditional industries that are doing software development, I say automotive, for example, or finance. Most customers in most industries these days are building apps for the Apple ecosystem, whether it's an Apple iOS app or an app for the Mac OS. So on GitLab or GitLab Runner, I should say, we give you the flexibility to install the runner, on your macOS platform. And not only that, but our new autoscaling architecture, we support autoscaling macOS runners on certain hyperscalers. But if you're on GitLab.com, you don't have to worry about some of that heavy lifting. So it's a really good value proposition to consider. It's like, hey, if I have a few teams that are building apps for the Apple ecosystem, does it make sense for me to allow building some of that application profile, building those apps on the GitLab SaaS and macOS runners? So a lot of considerations in terms of what one might need to think about. But the bottom line is, the first thing is, hey, it's super flexible. To get going on day one in GitLab.com, you don't have to worry about creating your own runner fleet or managing your own runner fleet. But if you have that need, then yeah, you have the flexibility to go ahead and do so.
That's great, Darren. Thank you. That brought up a few considerations I hadn't thought about before. So that's really helpful. So
that's awesome. Thanks.
Yeah, one of the things we talked about in this webinar a little earlier on was the new GitLab autoscaling Docker and instance runners that have gone from experimental to beta. What would you think would be some of the primary advantages to using those new runners?
Oh, wow. That's a great question. I actually had a conversation with a customer last week, Friday. 4 o'clock. It was a really good conversation. So it was a really good start to the weekend. What we were talking about, just exact question. I'll use this customer as an example, Brian, to kind of frame my response for your question, because I think it might resonate for some other folks.
Sure.
So this customer has been a GitLab that has actually been, it was interesting, a GitLab.com customer for a few years, So they're on GitLab.com, but they are actually, in fact, self-managing their own runners on AWS, on the Amazon.com as hyperscaler platform. Their current runner implementation, and I forget what kind of workload they're running. I think it's in the thousands per week in terms of CI jobs that they run on the environment.
Okay.
The current implementation is for runners on AWS is that they rely on auto-scaling groups in AWS, which is fine, which is obviously a very mature pattern for using compute on Amazon. So the runners and auto-scaling groups, if I recall from the conversation with this customer, is approximately 700 auto-scaling groups.
Okay, wow.
And each auto-scaling group, there is a runner. And then they use infrastructure as code, or IAC, to manage the auto-scaling groups, spin them down, spin them back up, recreate the runners, have the runners reconnect to GitLab, do all that sort of hygiene and maintenance,
Okay.
The conversation on Friday was about, hey, this is great, but we're now in the need, and this is a conversation I was having that we now need to be able to better manage the scaling of the runners. We don't want to have a whole bunch of runners out in the environment when we don't need to. Can we build more hooks into the runner itself, Darren, to enable us to shut down, unused runners when, the demand is not there? And so on and so forth. I was like, well, I'm glad you asked. And the answer is yes. And that's what we have with the new autoscaling solution, which we're calling Next Runner Autoscaling. But under the covers, there are two new pieces of technology that was developed by our engineering team, one called Fleeting and one called Task-Scaler. So long story short, the benefits of the new autoscaling technology gives you is that this particular customer can theoretically, and it was an easy sort of potential POC for them, they can start off with the 700 AHGs. That's fine, but they have an opportunity to reduce that. But with the new model, you install a runner on your AWS environment, in your AWS environment. Let's just say for a moment you install an AWS virtual machine instance, and that runner you install becomes a control plane for autoscaling other runners.
Okay.
Right? So we call it a runner manager when it's acting in the control plane, which is kind of a Kubernetes construct kind of a thing. You install the runner, you configure it to use the new autoscaling executors, right? And you install, oh, I can't see that properly. You install our AWS plugin. So our new technology is a plugin-based framework. So we have plugins for Amazon Web Services, we have plugins for GCP, we have plugins for Azure. Customers can theoretically build their own plugins for other hyperscalers that we don't support, whether those that are only cloud, provided cloud hyperscalers, or even on-premise, hyperscaling technologies like a VMware potentially, or even an OpenStack.
Nice. So
you install the runner, you install the plugin, and then the runner, that control plane, that low-cost, always-on runner control plane on a, not a very expensive virtual machine is our recommendation, will be able to handle the auto-scaling, the auto provisioning of new runners for workloads, new VMs, and tearing them down. Plus, it gives you a bunch of configuration capabilities in terms of scheduling. Like you can decide how many runners you want to have pre-warmed or pre-ready to go during high peak times during the workday or during the business day. Over the weekends, you can say, okay, I want to have no runners pre-warmed. I want to drain my fleet down to zero. You can have that as well. So you've got all that great functionality. The last thing I want to call out, which is really super interesting, especially for folks that are on AWS, the new technology allows you with the one runner manager control plane to spin up virtual machines that are running on Linux. So you can have a virtual machine spun up on Linux with a runner running the Docker executor. On that same runner manager control plane, you can have virtual machines that are spun up on AWS that are running Windows. And you can have virtual machines and or instances, to be more specific, that are spun up using Mac that AWS is offering. So one runner can service the needs for all three of those compute architectures with the new technology. So we're super excited about the flexibility that it gives customers. And the other thing that we're really keen about, which again, I have to tap my hat to the engineering team because this was their brainchild, was the manager works with autoscaling groups. So in this particular customer's case, they don't have to recreate those autoscaling groups. They could probably reduce some of them, but I think they have the 700 because of security boundaries. So that's just shows you how complex some of these security compliance rules become. But the good news is they don't have to recreate them. They just point the runner manager to the existing ASGs and make one configuration change in ASGs, and they're off and running.
Wow, that's exciting. I know a lot of customers are waiting for this to get into GA, so I can see why. That's a pretty compelling solution. As a follow-up on that, some customers have indicated they would like to, using the Fleeting plugin or the auto-scaling runners like you mentioned, the next gen, they want to have ephemeral runners that run only a single job and then exit. Is there a configuration or executor that we would recommend for that kind of application?
Yeah, absolutely, Brian. The answer is yes. It's either the instance executor or the autoscaling executor that comes as part of this new autoscaling solution. And there is a configuration option in there that allows you to run jobs only in one ephemeral virtual machine per job.
Okay.
So the difference with this new autoscaling and the older technology is that customers have the option of saying, okay, Yes, I want to flip that configuration so that each job runs in a one-time use only virtual machine, and then after the job completes, tear it down. They also have the flexibility, however, if their needs determine so, to flip that the other way and actually run multiple jobs in a virtual machine. So
Okay.
we've given them the flexibility, and it's a very simple configuration option in the config.toml file, the thing that manages the configuration for the runner to set that option for them.
Excellent. That sounds great. Thank you. A question that's more probably for around docs and things like that is, do we have documentation available for customers who maybe want to go that extra step and really ensure their runners are secure?
Yeah, we actually, that's a great question. We do. And it's in our documentation page. You go to the docs page on GitLab.com, you go onto the runner section,
Okay.
and I forget the exact menu item where it's at, but if you type in security, there's a whole section in terms of considerations, not just for runner security, but for CI security in general. And
Yeah.
so the one thing that customers, and customers are probably aware of this as well, but just to reiterate, right? CI platforms are very powerful in terms of what we allow folks to do. And one commentator in the industry put it this way: it's really a remote execution service, right? You are allowing a remote compute substance somewhere to execute scripts on your behalf, right? And
Right.
so you're allowing the remote thing to pull down your project repository using Git pulls, right? Right? And then run these scripts on it, whether it's make for C++ or you're doing an npm build for Node.js. So
Right.
it's right a very powerful automation engine. So just like any sort of best practices from a network security standpoint, one might have been needs to consider over the last 30 years or so, is the same sort of like consideration you want to have. Okay, who has access to my environment? Do I have the right controls on my environment, right? Who has access to my project repository, right? Who has different rules to do things, right?
Sure.
So it's not just thinking about securing the runner or the host on which is running the run is executing the job. That's super important as well. But having that 360-degree view and understanding of all of the different touch points from a security perspective. And GitLab gives the customers that view. It's like we have roles, you understand who's doing what from a commit perspective, et cetera, et cetera. And then as to wrap up, specific to runner, there's certain things that we call out currently in the security doc. I haven't looked at it in a couple of weeks or so, but things like thinking about Docker builds, which is always an area of concern for customers in terms of how Docker has traditionally approached container builds by needing what is termed like privileged access to the environment and considerations for
Right.
that, and so on. So we cover some more esoteric things in that security doc as well.
Excellent. So kind of my takeaway on that, Darren, is yep, make sure your runners are secure, the hosting for those is secure, but really to get the big picture, you want to look at the entire pipeline from beginning to end as far as security goes. Is that a good synopsis?
Yeah, security is always a 360-degree concept, the way I frame it, right? Do you know who has access to your project repositories? Are you doing hygiene there, right?
Right.
Right? And then as you're looking at, if you're obviously in the case of where you're self-managing your own runners, some customers have, I mean, they're very much very well advanced in this, right? They have like using AWS as an example, and we have other cloud hypervised hyperscalers that we work very closely with as well, like Google. And so this applies across, all of these hyperscalers that we partner with. Segmentation of teams into different virtual private networks, right? Reducing sort of like the boundaries in terms of like, hey, I shouldn't just because I work at GitLab have access to maybe your network security boundary and those types of things. So all of those things are part and parcel of just good network security and good security practices anyway, and just building on that as you deploy GitLab CI runners if you are in fact going to manage your own runner fleet internally.
Great, thank you for that. So last question for today. How would a customer approach setting up redundancy for runners?
Now, that's a great question. I think a couple of different ways, but a really easy kind of pattern to think about is just kind of basically the one we use. That's just kind of, but it's the one we use on GitLab.com. So one of the very, I, I'm not sure this is a very good technical term, but the only thing that comes to mind. The cool things about Runner is and GitLab CI, it's just this ease of use and flexibility,
Hmm.
right? I think sometimes it gets lost a little bit in all of the great things we do in the DevSecOps platform. But any customer that's thinking about adopting GitLab or is adopting GitLab and migrating from existing tooling, right, and so on, it's really need to understand that with GitLab CI, getting started is super easy, right? You create a project repository, you add a pipeline file, and
Yeah.
if, like for example, you're going to self-manage a runner, you quickly install this runner on the environment you want to, and you're up and running. And GitLab CI is ready to scale up for you and run. And what makes it so simple to get going is that we rely on a tagging mechanism in order
Hmm.
to link a runner to, say, a GitLab instance or get a GitLab group or project. So, for example, in GitLab.com, we have multiple runners that are tagged the same way. So
Okay.
this means that as a CI job comes in that needs a Mac OS runner, for example, we've got 2 or 3 that are tagged with Mac OS and some other tagging parameters that can handle that job. So if one of those runner hosts go down, of course, we want to, quickly get it back online because we want to make sure we have capacity. But any of the other hosts can pick up that job. So it's as simple as having multiple runners with the same tags gets you redundancy on day one. Other customers have more advanced patterns where in a hyperscaler, they may have runners installed in multiple security zones,
Hmm.
right? In regions, sorry, I should say, security zone regions, and have IAC as code. But yeah, the runner mechanism out of the box, very simple. Create 2 runners with the same tag. You've got redundancy built in. It's pretty straightforward. And then the more advanced thing to think about as well, and we're building and we actually have a repo that's ready to go. It's called the GitLab Runner Infrastructure Toolkit. One of our staff engineers, Joe Burnett, came up with this idea. It's a toolkit of Terraform templates to help customers manage their runner fleet using infrastructure as code. So
Okay.
things like very quickly or easily creating runners in hyperscale environments, right? So customers today have probably been rolling their own Terraform or rolling their own CloudFormation. They can go to this repo, grab the templates, and have IAC as code to quickly roll out multiple runners with tags, with the same tags, et cetera, et cetera.
All right. Well, that's very helpful. Well, that wraps up our Q&A section. Thank you again, Darren, and hope to have a good rest of your day.
I appreciate it, Brian. Thanks a lot for having me on the call. It was awesome.
All right. Take care. That concludes our runner webinar. I would like to point out a number of additional resources that we recommend for your continued education. GitLab offers self-paced learning on Level Up. There are also webinars such as this one, which are offered on a monthly basis and cover a wide range of topics. GitLab's professional services team provides privately led training specifically for your organization. And last but not least, please feel free to reach out to a member of our customer success team to learn more about a topic of interest to you. Thank you for attending today. We appreciate you taking the time to join us. All the best.